Okay, in this tutorial, we're going to have a look at how to use polar graphs and circular graphs, as well as the suitability of these techniques in terms of presenting data. So first of all, let's have a look at the polar graph. So the polar graph is used as a graphical technique to show the direction that data is being gathered at. So one of the key conditions of your data must be that you have gathered it with a direction component. So for example, here we can see how frequent is the wind blowing from the main directions on the compass, with north, east, south, and west clearly indicated. The actual way your data is formatted, whether it is in interval values or in this case percentages, it doesn't make any difference, but you do have to then create a scale with the middle of the polar graph being 0, and this being whatever number you choose it to be. And then what it can clearly show you is which direction is the most frequently occurring in your data set. So for example, we can see southeast is the most frequently occurring, and it's got over 10%, and we know that because we can see it comes up this far on the graph. And if we just follow this around the edge of the scale, we get to see that it must be around about maybe 12% frequency that the wind is blowing from this direction. Each of these can then be further subdivided into how strong the wind is blowing when it blows from that direction, and we can use this color-coded scheme to determine that, for example, the wind strength that's the most commonly occurring, doesn't matter which the directions you are, is the orange, and we can see between 0.5 and 2. But we can see in the southeast, we've got this very strong purple, 4 to 6 degrees, for example. And it gives you an idea of 2 bits of data presented using the same graph. Now, it's commonly used to present wind direction because it has a directional component. Flows past a location of anything, that's something that's moving from one place to another, can be obviously used presented using this technique. And for example, even things like corries in a country, for example, Scotland, because every corrie faces a certain direction. And if you looked at a corrie and recorded the direction it was facing and did that for every corrie in Scotland, you could actually find out what was the most commonly occurring direction. And that is based on the idea that corries tend to form in cooler locations, for example, north-facing slopes. So the polar graph is a powerful technique used for presenting data that has been gathered with a directional component. It can be, one of its limitations, can be quite difficult to interpret for non-geographers because it's an unusual way of presenting data. It can be highly effective if you've got multiple bits of data for each direction. For example, in this example, we've got all the different wind speeds for each of the directions. So we're presenting not just the most commonly occurring wind direction, but also what the most frequently occurring wind speed is. So we can present more than one piece. It's also very good at identifying areas where there is no flow. So for example, we can see very little north-northeast, northeast, and east-northeast, as those 3 directions are significantly underrepresented on this particular graph. So we can get to see a kind of pattern and trend using this. Now, there's a very similar technique that employs the idea of a circle, but in this case, we're presenting a slightly different piece of data. If I just go down to it. Here, we're using the circle to represent a period of time. So for example, here we've got a 24-hour period, and starting at midnight, going all the way around. And we've got a scale going from 0 to 160, and we could count the number of pedestrians at midnight. We can see there's none at 1 o'clock. We actually don't see the first one appearing till this little point here, which is around about 4:30 a.m. And then we get our first significant number of people around about 6 a.m. We can see a peak around about 9 a.m. So it's a very impactful way of showing a trend, and you could actually do multiple days. So if you did every day of the week in one location across a 24-hour period, you could have each day just using a different color, so that all the lines could be put on the same radial, but just the blue could represent the Monday, an orange could represent the Tuesday. What would that then allow you to do is it would allow you to compare the flows of each day. And for example, you might expect Saturdays and Sundays to be busy. You might also expect maybe Friday nights to have much more people out at a later time because those are nights when people go out. Depends where you are in a city, of course. So that's a radial graph that we've just looked at. just like with the polar graph, it can be quite difficult to interpret to somebody that's not familiar with it. And if you start putting multiple lines on it, it can start to become a little bit confusing, which is what we see in our next example. However, this is a slightly different. This, unlike the other two, each of the spokes isn't a time, or in this case, a direction on the compass. Each spoke represents an environmental quality factor. So we've got 5 factors we're mapping here, and each of them could have a potential score between 0 and 10. And we can, for example, see that South Street is scoring very high in all of the categories, compared to North Street, which is scoring very low, but not in all categories. So we get, by putting multiple lines, we can compare again. However, once you start adding more lines, you can see it can become a little bit confusing, especially to somebody who's not familiar with it. Please feel free to read through some of the other reasons for using the technique and limitations, and be prepared to possibly use it as a technique to present data if applicable in an exam question, or if you're asked specifically about it as a technique, then be able to discuss its suitability, strengths and weaknesses as a technique.